Good day everyone, I'm Divina Machas together with Frank Castro. We will be discussing lesson 13 which is generator. Generator is a device that converts motive power into electrical power for use in an external circuit. Sources of mechanical energy include steam turbines, gas turbines, water turbines, internal combustion engines, wind turbines, and even hydrants. Electrical generators are a standalone machine that provides electricity when power from the local grid is unavailable. Industrial generators are often used to supply backup power to facilities, businesses, or homes during power outage, but they can also be used as a primary power source in area where a local electrical grid is unavailable or difficult to access, such as mining and farming operation or even new developments and constructions. There are 9 parts of generator. 1. Engine. 2. Alternator. 3. Fuel system. 4. Voltage regulator. 5. Cooling and exhaust system. 6. Lubrication system. 7. Battery charger. 8. Control panel. 9. Main assembly or frame. Engine. The engine supplies energy to the generator. The power of the engines determines how much electricity a generator can provide. Alternator. This is where the conversion from mechanical energy to electrical energy occurs, also called a genhead. The alternator contains both moving and stationary parts that work together to create the electromagnetic field and movement of electrons that generates electricity. Fuel system. The fuel system makes it possible for the generator to produce the energy needed. The system includes a fuel tank, a fuel pump, a pipe connecting to the tank to the engine, and a return pipe. A fuel filter removes dirt bits before it gets to the engine, and an injector forces the fuel into the combustion chamber. Voltage regulator. These components help control the voltage of the electricity that is produced. It also helps convert the electricity from AC to DC if needed. Cooling and exhaust system. Generator create a lot of heat. The cooling system ensures the machine doesn't overheat. The exhaust system direct and remove the fumes that form during operation. Lubricant system. There are many small moving parts inside a generator. It is essential to lubricate them adequately with engine oil to ensure smooth operation and protect them from excess wear. Lubricant levels should be checked regularly, as often as every 8 hours of the operation. Battery charger. Batteries are used to start up the generator. The battery charger is a fully automatic component that ensures the battery is ready to go when needed by supplying it with a constant low level of voltage. Control panel. The control panel controls every aspect of generator operation from startup and running speed to the outputs. Modern units are even capable of sensing when power dips or goes out and can start or shut off the generator automatically. Main assembly or frame. This is the body of generator. It is the part that we can see, the structure that holds in it all place. How do generators create electricity? Generators convert mechanical or chemical energy into electrical energy. They do this by capturing the power of motion and turning it into electrical energy by forcing electrons from the external source through electrical circuit. A generator is essentially an electrical motor working in reverse. What does a generator do? Electric generators are essentially lifesavers. They are backup power sources that convert fuel supply, usually propane, diesel, or gasoline, into electrical energy. They are the primary sources of electrical supply during power outage. This energy is used in an external circuit. Unlike standby generators, the following are not permanently installed in one place, so they are easy to start. There are 5 types of generator. Portable generator. A portable generator is powered by gas or diesel fuel and can provide temporary electrical power. Here are some characteristics to note about this type of generators. Uses a combustion engine to conduct electricity. can plug into electrical appliances or tool via its sockets, can be wired into a facility sub-panels, can be used in remote sites, has enough power to run a television, freezer, and refrigerator. The engine should run at 3,600 RPM to render the standard 60 Hc of current. Use of governor to control the engine speed. Can power tools and lights. Inverter generator. An inverter generator uses an engine connected to an alternator to produce AC power. It also uses a rectifier, unlike other generators, to convert the AC power into DC power. Here are some characteristics to note about this type of generators. Relies on high-tech magnets, uses advanced electronic circuitry, undergoes 3 phases to produce electricity, output AC current, convert it to DC current, and finally invert it to AC. Maintains a constant flowing of current to an appliance, is more energy efficient as the engine speed adjusts itself according to how much power is needed. Its AC can be set to any voltage and frequency when used it with proper equipment, tends to be little and lightweight, can fit into a car, RV, or boat. Standby generator. A standby generator is an electrical system that operates with an automatic transfer switch that commands it to power a device up during power loss. Here are some characteristics to note about this type of generators. Operate automatically, delivers permanent power protection, has 2 components, a standby generator and an automatic transfer switch, can operate on liquid propane or natural gas, will run on the fuel type already in use in the facility or home, uses an internal combustion engine, sends the power loss within seconds and boosts up electricity so that the power loss is felt very briefly. Exuses automatically weekly self-tests to see that it's properly reacting to a power loss. Is constantly monitoring utility power. Used in safety system for elevators, standby lighting, medical and life support equipment, and fire protection system. Industrial generators. Industrial application of generators are very different from residential or small commercial applications. Industrial generators or large commercial generators need to be more robust or run and perform under harsh conditions. They also need to provide a wide range of power supply characteristics, from 20 kW to 2,500 kW, from 120 to 48 volt, and single phase to 3-phase supply. Typically, these generators are more customized than other types of generators. Induction generators. These comprise 2 types, externally excited generators and self-excited generators. Externally excited generators find uses in regenerative braking application needed in hoists, cranes, elevators, and electric locomotives. Self-excited generators find uses in windmills where wine and a non-traditional source of energy gets converted into electric power.
How do you size generator for building? It requires you to take full load current measurements during peak usage to estimate the generator capacity. Divide the total amps by 2 for single phase current and divide by 3 for 3-phase current. Once you get the result, multiply it by the supply voltage and then by 1000 to get the result in kilowatt. So here's the diesel generator fuel consumption chart in liters. This chart shows the generator size and its approximate diesel fuel consumption. Generator set foundations. Foundations supporting generator sets must meet flotation, alignment, and vibration parameters for successful operation. Specifications that consider the following criteria will help assure trouble-free installation and operation. Foundation must be able to withstand the installation's weight and prevent deflection. To determine the pressure exerted by generator set, use the following equation. P is equal to W over A, where P is equal to pressure in PSI, W is generator set weight in lbs, A is equal to area in square meters, inches, of the rails, pads, or vibration mounts. This pressure must be less than load carrying capability of the soil foundation pad. General load bearing capabilities of underfoot are listed in Table A. Table A, bearing load capacities. So, here in this table, shown are the materials and safe bearing load. In materials, rock hard pan is 70 in PSI and 482 in kPa. Hard clay gravel and coarse sand is 56 in PSI and 386 kPa. Loose medium sand and medium clay is 28 in PSI and 193 in kPa. Loose fine sand is 14 PSI and 96.4 kPa. Soft clay is 0 to 14 PSI and 0 to 96.4 kPa. The foundation should weigh at least as much as generator set's wet weight. Equation to calculate the necessary foundation depth. Foundation depth or thickness is equal to W over D times B times L, where W is the total weight of genset, D is the density of concrete, B is foundation width, and L is foundation length. This equation assumes a concrete mixture of ratio of cement, sand, and aggregate with maximum 4-inch slump and 29-day comprehensive strength of 3000 psi or 20.67 megapascal. If no vibration isolators are used, the floor must support 125% of the generator set weight if generator sets are paralleled. Possible out-of-phase paralleling could cause torque reactions. Here, foundation must be designed to withstand twice the generator set wet weight. Outside base dimensions should extend beyond the unit a minimum of 1 foot. On all sides, foundation footings must extend below the frost line. The foundation should be reinforced with number 8 gauge steel wire fabric of number 6 reinforcing bars on 12-inch centimeters horizontally. Bars should be embedded in the concrete at least 3 inches from foundation surface. Service considerations. Convenience and serviceability can be designed into a generator set foundation. Consider specifying conduit for electric starting system, generator leads, and fuel and water connections. Generator set vibration isolation. No isolation is required to protect generator set from self-induced vibrations. Caterpillar gensets are designed to absorb all normal vibration created internally as well as most external shock loads. This is not true of the genset environment. Idle gensets, auxiliary equipment such as relays and switches, and building structures can be adversely affected by vibration from an operating genset. Vibration types. There are two types of generator set vibration, which is torsional and linear. Torsional vibration results from combustion forces imposed on the engine crankshaft that is transmitted to the total rotating mass, except in unusual installation, proper matching of engine and generator set at the factory completely avoids this type of vibration. Linear vibration has many causes and can usually be linked to shaking and noisy machinery. Its exact nature is often difficult to define without instruments, because total vibration measured is approximately a sum of vibration sources. Engine produce vibration due to combustion forces, torque reaction, structural mass and stiffness combination, and manufacturing tolerance on rotating components. These forces create a range of undesirable conditions ranging from unwanted noise to high stress levels and ultimate failure of engine or generator components. Vibrating stresses reach destructive levels at engine speeds when resonance occurs. Resonance occurs when the system's natural frequencies coincide with engine excitations. Vibration effects. There will always be some vibration rotating machinery like an operating genset, so it is good practice to specify isolation of the unit. The unit should not rest directly on rock, soil, steel, or concrete. These materials can transmit vibration long distance. Resonance of certain genset frequencies with natural frequencies of building structural members can cause damage to some type of construction. Separating the genset from surrounding can be done with a bulk isolator such as Inertia block or with commercial isolators. The bulk isolator is the most expensive and elaborate of the two systems. It consists of massive block on which the genset is mounted. The block is surrounded by cork or fiberglass, separating it from the surrounding structure. Rubber pads are sometimes used to dampen high frequencies which can cause noise, but the most often used device is the spring-type isolator. It offers about 95% isolation of all vibration and eliminates the need for an inertia block. Spring isolators are placed under the genset rails but are not bolted to the floor unless the unit is paralleled with another generator sets or in an earthquake-prone area. Spring isolators are most effective when located directly under the engine and generator mounting sheet. So here's an example of vibration isolators. Here is the detail of generator pad. Here in this figure, it shows the parts of the generator and all of its components. So here's our sample problem. Using allowable bearing capacity of soil of 96.4 kPa from Table A and data below for weight and the dimension of base of generator, determine the dimension of generator pad without a vibration isolator. So here is our solution. Weight of generator set is equal to 1,276 kg, then convert it into kilonewton, which is 12.52 kN. Weight of pad is equal to weight of generator times 125%. Weight of pad is equal to unit weight of concrete times L times W times T. Using 300 mm extension on both sides, length is equal to 3037 plus 600 is equal to 3637 mm. Then width is equal to 1110 plus 600 is equal to 1710 mm. Then the next thing to do is solve for the thickness of pad. 23.5 kilonewton meter cube times 3.637 meter times 1.710 meter times T is equal to 12.52 by 1.25. T is equal to 0.107 m. So use 0.20 m or 200 mm. Thus, pad dimension is 200 mm by 1710 mm times 1710 mm by 3637 mm. Check for bearing pressure of soil. Weight of pad is equal to 23.5 kN over meter cube times 0.20 m times 1.71 m times 3.637 is equal to 29.23 kN. Total weight to be supported by soil is equal to 29.23 kilonewton plus 12.52 kilonewton is equal to 41.75 kilonewton. Actual bearing pressure on soil is equal to 41.75 kilonewton over 1.71 meter times 3.637 meter is equal to 6.71 kPa. Soil has an actual bearing pressure of 6.71 kPa, which is lesser than 96.4 kPa. Therefore, use 0.20 meter by times 1.71 meter times 3.637 m pad for foundation.